In this video, we discuss the energy and power in signals. You might have learned different definitions of energy and power in different courses. The definition of energy and power we defined in communication system. Here, that's what our definition. For energy, this is curly E, Ex. We take the magnitude squared, and then we take integral from minus infinity to infinity. And also we can write in this way, if I take minus half t to half t, and then we let t goes to infinity, and the integrand is still the magnitude of xt squared. Here I see magnitude because xt may be complex signals, such as complex exponentials. They are complex signals. So in that case, that's a magnitude squared. For example, 3 minus 4j, this is a number. I just use this example to illustrate the complex numbers, how we get the magnitude squared, okay? So magnitude squared, real part squared, plus the imaginary part squared, in this case, 25. If the signal is real, the magnitude is really the absolute value squared. So if we take minus 4, the absolute value squared is really minus 4 squared. This is the same thing that they're equal in the case 16, right? Let's introduce the energy type signal. The energy type signal, if and only if the energy is finite, which means that this energy can be specified by some certain numbers. It cannot be infinity. Let's use this example to illustrate how we calculate the energy. So ext equals to A cosine 2 pi f naught t plus theta. We always start with the definition when we calculate the energy or power. So the definition is very important. In this case here, it's really easy to see this goes to infinity because, as I said, this is a real signal. So that equals the real signal squared 2 pi f d of t. And you can see here, everything is positive. This is a positive, everything positive, everything. In sum of positive numbers from minus infinity to infinity through the whole real line, of course, it goes to infinity, right? Next, let's look at the definition of power. So power is the averaged energy, that's roughly speaking. We take the energy from minus half t to t. We take magnitude squared of xt, and you do this integral, and then we divide it by t. We take the average in the time, and then we let t goes to infinity, and this quantity is the power. Let's look at the signal. What's the power in the signal? Again, definition, p of x, here t goes to infinity, 1 over t. We do integral from minus half t to t, and then x magnitude squared, because this is a real signal, is really xt squared. Xt magnitude squared equals to xt squared, and notation is x squared. We take the squared of xt, that's a squared cosine squared, right? A squared cosine, and then you do the integral. Now we use triple identity. Triple identity, we use this. So we use this cosine alpha equals to half. So cosine alpha squared equals to half 1 plus cosine double alpha. You can have a small bracket here. So this is exactly what we did here. A squared here, a squared here. Cosine squared, I use this formula. That becomes half. I use different color. Half 1 plus double this angle here. Become 4 pi f naught 0 plus 2 theta. Then we take this term out. this term, we do the integral a squared divided by 2. You do this integral, that will be t, right? Minus half t. You do definite integral, that's t. And then there's 1 over t here, that's here. Cosine integral, this is in the ax dx. Also the formula in the formula sheet. So this equals to cosine, we do integral becomes sine. So sine, the same thing, ax, right? That's this angle. And a here, a is 4 pi f naught. 4 pi f naught, there's 2 here, become 8. I have 4 pi f naught here, and there's t here, and a squared from here. In this term, t and t cancel out each other, that's half a squared. This term goes to 0. So maximum sine anything, phi, that equals to 1, right? And minimum sine, that equals to minus 1. Now we look at this term. This term is definite integral, and then we need to plug in half t and minus half t in, right? So that will be equals to sine 4 pi f naught half t plus theta. So that's minus sine 4 pi f naught minus half plus 2 theta. We know maximum sine phi, any sinusoidal wave maximum value is 1. The minimum value is minus 1. So therefore, for any t, any value of big T, whatever big T is, the maximum of this difference cannot be greater than 2. So therefore, the maximum value of this definite integral in this portion, in the yellow highlighted, that's 2. So if we take 2 here, and then this portion here, and then we take t goes to infinity. Of course, those are constant. A squared constant, 2 is constant. You have this big T in the denominator, but t goes to infinity. Of course, this goes to 0. So what's the energy in this sinusoidal signal? That's a squared divided by half, magnitude squared divided by half. This is the power content in this cosine signal. Now we can see for this signal, the energy we calculated goes to infinity. The power equals to the magnitude squared divided by 2. So for this signal, it is not energy type, but it is a power type signal. If we notice that this xt equals a cosine 2 pi f naught t plus theta, if we notice this signal is a periodic signal. For this general case, for any periodic signal with period t naught, we calculate the energy using this definition. This is the same definition we defined here. Either this one or this one, both are okay. They are both equivalent. So we take minus half t to t and take the magnitude squared, do the integral, and let t goes to infinity. And note this big T and this T naught are different quantity. So because this is any periodic signal, I can choose this big T equals to n T naught. N is a positive integer. I can choose this way. As long as I have this big T goes to infinity, I'm okay. So now if I plug in big T equals to n T naught, here, and t goes to infinity really is n goes to infinity. And after a little organization here, and this is equals to m, we take this is n period. We really integral this signal in n period. So I take n out. Now I take 1 period integral now. What is this? Because you take 1 period integral magnitude squared, always positive, and this term always positive. And then you multiply by n, and let n goes to infinity. Of course, this quantity goes to infinity. So therefore, we can see the energy content in any periodic signal that's infinity. Any periodic signal is not energy type signal. So now to calculate the power, we do the same trick. We let big T equals nt naught, and we take time average 1 over t, that equals to nt naught. And then we take this n out because this is an n period integral. That really is equals to n times the integral in one period. N and n now cancel out each other. The power is we take one period integral of the magnitude squared divided by the period. This is a finite. It is a finite number. So therefore, periodic signal is energy type signal.